Hello everyone, my name is Isaac from International Marketing at VINNO, and welcome to our launch event. For more than 1 decade now, VINNO becomes one of the most rapidly growing brands in ultrasound imaging. Thanks to the close partnership, VINNO is delivering ultrasound systems and services in more than 100 countries. At VINNO, we have a vision: innovation for a better life. We believe the products should be designed to make your day easier, so you can spend more time on what matters. It is with this commitment we are proud to launch the new generation of ultrasound system for general imaging, the Ultimus 9E, to be powered by MUSE technology, one of the most advanced software beamforming architectures. I'm thrilled to introduce everyone the new generation ultrasound system, the Ultimus 9E. I bet you're just as excited as I am about the new ultrasound system. Now, allow me to introduce you the project manager, Gavi Yin, to give you a tour of its inside out.
Thanks, Isaac. The Ultimus 9E ultrasound system was developed with a keen focus on ergonomics, image performance, and streamlined workflow to ensure clinicians have better diagnostic efficiency and focus on what it really matters: the patients. With 24-inch high-resolution monitor provides about 25% more lateral viewing information for a large image display, a high-sensitive Full HD touchscreen with 60-degree tiltable angle customizable interface to make viewing and workflow significantly easy. One button axis on the console panel for easy adjustment from left to the right, up and down, providing scanning comfort in any position. This premier ultrasound system supports 5 active ports plus 1 parking port for your extensive application needs. The water and dust prevention covered along with pinless probe connector to the greatest extent for transducer protection from the possible damage during daily use. As the image performance and system stability are always the top concerns for you, Ultimus 9E features the space capsule design of the console architecture. Its excellent heating dissipation ability, anti-electromagnetic interface, and noise isolation ensure the system delivers its best performance.
Ultrasound has become the indispensable imaging modality for screening and diagnosis. That's affordable and accessible healthcare solution, even at patient bedside. However, the fundamental limitations and trade-offs imposed by conventional ultrasound systems have curbed its further development. When we have the new generation ultrasound system in mind, we determined to break the chain and address the technological challenges. Let's hear from Gavi about the driven technology behind the new generation ultrasound system, the Ultimus 9E.
Today, I'm very excited to tell you the story of MUSE platform, which is our latest breakthrough software beamforming technology. It takes the extraordinary sonographic capacity to a whole new level.
In 2014,
We launched the revolutionary RF platform, which broke the limitation of hardware processing and demodulation of traditional ultrasound platform. This was the first platform which could support a 25 MHz frequency range. In 2020, a further advancement has been achieved with the VINNO platform. This adaptive beam correction technology enables much more sophisticated image performance. Today, we are here with the culmination of a long project we've spent countless hours together to develop the next generation of ultrasound imaging, the MUSE platform, which is the latest software-based beamforming technology in China. Ultrasound systems are complex devices. Multiple hardware components are put together, assembled to provide one relevant diagnostic image. The weakest link in this chain of components will force us to make trade-offs. Trade-offs like resolution versus frame rates, trade-offs like resolution versus penetration. The traditional ultrasound manufacturers develop a workaround to provide penetration with transmitting focus zone in the far field, which caused the loss of resolution in the near field. The other workaround is to create a second focus zone in the near field, but the cost is frame rate. This limitation impacts the doctors in a significant way, typically in tissue motion and Doppler imaging. MUSE technology provides a multimodal, ultra-fast, sonography-enhanced solution to break the physical limitations of conventional ultrasound imaging. MUSE technology represents the breakthrough of ultrasound imaging, breaks the compromises between spatial and temporal resolution. Compromise between resolution and penetration must be made in conventional approaches and can achieve both high speed and clarity of ultrasound image. MUSE is a software-based technology. It's a living technology with great potential for performance enhancements. It provides customers with regular and easy software upgrades to scale the product investment and keeps the Ultimus system at the cutting edge of image performance or excellence throughout the entire product lifecycle. Now, I'm about to review the working principle and the clinical applications behind the groundbreaking technology of MUSE platform. The underlying image technology on which MUSE is built is a unique tree model image acquisition. Its flexibility and powerful processing allow the system intelligence apply the most appropriate image acquisition mode from three modalities: line acquisition, zoom acquisition, and multiplane acquisition to reconstruct the best image presentation. As demonstrated in these graphics, the line image acquisition mode acquires and processes acoustic data in a line-by-line fashion. Each transmit beam is able to receive 128 acquisition lines. This advanced acoustic acquisition has the ability to form an image by utilizing a large number of the returning echo information. The zoom image acquisition mode utilizes multiple transducer crystals simultaneously in both transmit and receive, generates and acquires acoustic data in larger zooms. Each full frame of image information is received and processed approximately 3 times faster than with conventional beamforming platforms. The last, yet the most powerful, is the multiplane image acquisition, which allows for one full ultrasound image from one single transmit beam. Several tidal plane waves are then sent into the medium, and the backscattered signals are summed to produce a high-resolution ultrasound image at a very short period of time. In such acquisition, the system is able to achieve 400 times faster frame rates. By using this approach, the system is able to acquire and process a large increase in raw acoustic data, which can be used to significantly improve the tissue and blood motion in Doppler image and microbial motion in contrast-enhanced imaging. But how much faster? Let's first understand how both platforms work differently. Conventional ultrasound image is usually performed by line-per-line focused beam transmission. Each focused beam allows the reconstruction of one image line. The frame rate of the image mode is around 20 to 100 frames per second. MUSE platform technology, on the other hand, is performed by multi-tidal plane waves at image frame rates up to 20,000 per second, therefore average around 300 times faster. This incredible speed allows a full new range of applications and innovation in ultrasound imaging. The frame rate of linear transducer in contrast-enhanced image can reach 300 per second. It's about 6 times faster than conventional beamforming. With such significant frame rate improvement, CBI Plus can better track the perfusion of microbubbles, especially can better present the blood perfusion of small lesions with rich blood flow, and greatly improves visualization of vascular perfusion in the arterial phase. MUSE technology applies a different strategy for acquiring pulse-wave Doppler information, which can overcome the limitations of the existing modes by significantly reducing the required acquisition time. The second generation of PWV can measure pulse-wave velocities in the artery in less than 1 second. As our study has been confirmed that pulse wave velocity can be acquired 3 times faster than with conventional approach, and with this, increase the accuracy of the examination and reduces overall examination time. The multi-Doppler offers for the first time the ability to compare flow spectra and measurements from multiple up to 4 locations, which have been acquired simultaneously and therefore correspond to the same cardiac cycle and exhibit perfect temporal synchronicity. It allows a significant reduction of the vascular exam. Thanks to MUSE tree model image acquisition, the retrospective transmit focalization can be done dynamically for each pixel of the image, increasing the clarity and the uniformity of the final image compared to conventional beamforming platforms. For instance, the innovative acquisition technique combines multiple plane wave transmit signals to excel the conventional transmitter performance. This improves the signal-to-noise ratio by about 8 decibels and results in a significant noise-reduced data without compromising the frame rate. Thereby, R&D displays high-quality images for quick, accurate image analysis and diagnosis. The received signals from the scan fields are time-shifted and compounded to pixel level of entire scan field of view. This retrospective transmit field focus localization technique results in 20% more acoustic data acquired to form images with superior lateral border definition and contrast resolution than conventional compounding image. The MUSE platform technology brings improvement in penetration as well. The weak signals from the far field are enhanced multiple times when the signals are combined, providing increased lateral resolution and contrast at the greater depths of field. Image of the left is obtained using a conventional beamforming ultrasound platform with a single fixed focus zoom. As we move deeper into the image, lateral resolution begins to degrade and 1 mm pins begin to take on a split appearance until, as in the far field, they are not recognizable as pin at all. With MUSE platform, the image on the right demonstrates how the integrity of spatial resolution is maintained throughout the depths of field. This image technique improves the image quality in dense organs in technically difficult patients. To achieve the significance of MUSE technology, the image computation must be performed on a powerful software-based beamforming platform. For instance, the data rate required to perform real-time image is huge. It can be several gigabytes per second. Unlike the conventional beamforming, MUSE technology is built upon an enhanced parallel processing chain, which leverages the processing power of 2 GPUs, combining with FPGA and CPU as a software-based beamforming heterogeneous system architecture to enable full parallelization of image formation. Each personification can therefore lead to a full image. The advantages of this processing chain are the complete flexibility and the ability to quickly apply new and innovative algorithms. MUSE platform technology breaks the usual limitations and compromises of contemporary ultrasound. Thanks to its real-time capabilities, MUSE platform has great potential to fuel the development of Doppler image, neural image, contrast-enhanced image, vascular image, and shear wave elastography. MUSE platform is a breakthrough technology that can offer significant performance improvements and innovative capabilities to the field of medical diagnostic ultrasound. It offers high sensitivity, high frame rates, allowing high-quality visualization to expand the potential of ultrasound. We will with no doubt pursuing the future development of this technology and deliver more exciting features to provide accurate diagnosis for the patients.
The MUSE platform offers Ultimus 9E more available speed and more image clarity to support the high demand in premier clinical applications. Now, let me introduce you the product manager, Molly Shaw, to elaborate the highlighted clinical applications and its benefits.
Hi, my name is Molly Shaw. I'm the product manager for VINNO Ultrasound. Now you will have a chance to hear about the Ultimus 9E's excellent ergonomic features and the revolutionary MUSE technology from Gary. Now I'm going to shift focus to present how this system can make a difference for you. Thanks to MUSE 300 times faster frame rates to increase the temporal resolution, making Ultimus 9E to support high demand in premier clinical applications, such as high frame rate shear wave elastography, pulse wave velocity, and contrast bubble image. Let me introduce some of the new clinical features we launched on Ultimus 9E. For non-invasive stiffness assessment, the Ultimus 9E offers the real-time shear wave elastography, VShear Plus. For more sensitive motion detection, better stability, and higher accuracy. Vision Plus delivers more precise quantification of tissue stiffness, increasing diagnosis and prognosis for such as the characterization of thyroid nodules. Pulse wave velocity has been recognized as an effective method to evaluate carotid stiffness with higher producibility. PWV Plus allows a fast and reliable evaluation for the elastic state of blood vessels, thanks to the 20,000 ultra-fast frame rate of the MUSE platform. For local lesion diagnosis, CBI Plus offers a better visualization of tiny vessel perfusion and earlier diagnosis of tumors, thanks again to the MUSE technology's increased spatial and temporal resolution. With the microflow perfusion, even tiny vessel perfusion can be better visualized throughout arterial, portal, and lateral phase scanning. It greatly improves the clinician's decision-making for lesion diagnosis. The Ultimus 9E has equipped with advanced 3D rendering techniques. The 3D structure display of fetus is now part of the daily obstetric practice. The conventional 3D image lacks partial light and shadow effects, and has the limitation of highlighting some specific 3D tissues. The Light Lab technique is a superior 3D obstetric visualization tool, which also supports the customization of the position and the direction of the virtual light sources to display more structured details and achieve a more realistic scenario. Another advanced volume rendering technique is Color 3D, which allows a true 3D visualization of morphological information with hemodynamic flow. It provides vascular structures with increased deep perception and improved spatial resolution of hemodynamic flow to obtain a deeper understanding of relational anatomy and neighboring vessels, such as fetal circulation, umbilical cord, and fetal heart. Color 3D is available on both color and power Doppler imaging. In conventional PW measurements, the user constantly goes back and forth between CF mode and the PW mode as the region of interest to acquire quantitative measurements. Triplex can improve the user workflow. However, some compromise on the PW spectrum quality have to put up with. Thanks to the MUSE platform, multi-Doppler can display two Doppler waveforms from separate same gates during the same cardiac cycle. The combination of TDI and PW allows simultaneous evaluation of wall motion and hemodynamics, which enables faster and more accurate measurements of left ventricle diastolic dysfunction and carotid stillness. The optional modes include PW and PW, PW and TDI, TDI and TDI. Leveraging the advanced three-modal image acquisition of MUSE technology, Ultimus 9E delivers both more clarity and uniformity of overall image than the conventional beamforming platforms. The unique adaptive signal processing technique, Tissue Boost, automatically analyzes the echo signal in specific region of interest to enhance the weak echo signals while suppressing the surrounding cloud noise, providing more imaging uniformity and improved visualization of tissues. Another unique breakthrough technique that the Ultimus 9E provides is adaptive sound speed, which automatically samples and analyzes different tissues to be examined and determines the optimal signal speed needed for improved overall image quality. This one-touch and intelligent imaging processing tool improves lateral, spatial, and contrast resolution and image at depth. Artificial intelligence has beginning to play an important role in ultrasound imaging to reduce the time needed for routine tasks and allow more time to perform tasks that add value and influence patient care. VINNO is already looking at the future and has introduced tools that allow you to do what you do best. Focus on patients. Till today, VINNO is providing the ultimate intelligent solutions for women, children's healthcare, and radiology. Enables Ultimus 9E to deliver truly intelligent solutions from pre-pregnancy evaluation, pregnancy, postpartum recovery, neonate, and radiology. I can't wait to tell you more about the new intelligent features launched on Ultimus 9E. The big leap we will make in the intelligent solutions is Women OB, which offers an absolute extensive obstetric screening solution. By harnessing the power of deep learning techniques, Women OB automatically captures and stores the standard planes with fetal biometric measurements in real time. Based on ISUOG practice guideline, Women OB is so far the only intelligent obstetric screening tool offers up to 28 standard planes can be detected. Simply scan and let Women OB do the rest for you. Earlier detection, screening, and earlier intervention are essential for diffuse liver disease, such as non-alcohol fatty liver disease, endorsed by deep learning techniques. V8 liver detects common focal and diffuse disease of the liver in real time. When the frame is frozen, the lesion can be outlined, and the system will automatically provide the description and the size of lesion. V8 liver significantly improves the efficiency and the diagnostic ability of doctors in primary care for earlier screening and detection of liver disease. Thyroid nodules are exceedingly common, leading to costly interventions for many lesions that ultimately prove benign. V8 thyroid provides an invasive and safe approach for detection and assessment of thyroid nodules to avoid unnecessary interventions. It performs the real-time analysis empowered by deep learning algorithm, which automatically detects and recognizes the single or multiple lesion during scanning, and displays the size, border characteristic, and the tie-race classification. This will reduce diagnostic ambiguity and improve clinicians' decision-making, leading to overall reductions in unnecessary biopsy and diagnostic surgery. By using AI, we are pushing limits and enhancing diagnostic capabilities, at the same time, functionally making exams easier and faster. The ultimate intelligent solutions built into Ultimus 9E is so advanced and powerful. It is our responsibility to push it even further by using it, by challenging it, and showing it makes a difference for you.
What brings VINNO forward is the passion we have for ultrasound imaging. For the last decade, we have been pushing the boundaries of sonography to provide ultrasound solutions for more patients can have access to. We are confident that the premier performance and the most intelligent solutions available for Ultimus 9E can make it an ultrasound system that delivers on all fronts without compromise. As always, our goal is to bring innovation for better patient care and a better life. With that, I want to say thank you for taking the time out of the busy day to join us for the launch of our Ultimus 9E ultrasound system. And also, I'd like to invite you to visit VINNO's website to learn more. Be well, and we will see you soon.